All right. Did we do flow control yesterday?
Yeah.
Good. We're all happy with flow control. No, with error detection. Oh, we started the flow control. Yeah, we did the flow control, right. Okay, quick one. What's the window size? What's the definition of a window size?
Oh, it's amount of frame that can go unacknowledged, that the sender can send unacknowledged.
Okay, good. The number, not number of frames. The maximum number of frames the sender can send. So the unacknowledged maximum number of frames that are unacknowledged that the sender can send. Right. And did we do a negative acknowledgement yesterday? Did we do it? No. Right. Positive acknowledgement. What does acknowledgement 5 mean? Any idea?
Things.
5 things. Go on. Give me one more two things.
Yeah, the receiver is receiving all the packets up to 75 and expect 5.
Start again. You receive acknowledgement 5. What does it mean?
The receiver has received all the packets until 5 and
Up to and including number 5 were received correctly.
no, not including 5.
Not including 5. So it will be clear with that in your answer, right? Good. What else could it mean?
Maybe it's expecting the frame number 5.
The receiver is expecting to receive frame number 5 next. Anything else? With an acknowledgement 5 mean? Anything else? If you receive acknowledgement 5, what would it mean? What would it actually receive? Yeah, we said two things. All frames before 5 are acknowledged received, and expect number 5 next. Any other meaning, guys?
5 and after 5.
Send number 5 and follow. Yeah, okay, that's the expected. Anything else? Could it mean a lost frame or a frame with an error? It could mean, hey, frame number 5 has a problem. This one.
Yeah.
If you've already sent 5, if you sent me 4, 5, 6, and 7, I send you acknowledgement 5, what does that mean? It means I received up until number 4, and there's a problem with number 5. Could be lost, could be contains an issue or a problem. Okay, so if there is a lost frame, if a frame is lost, who would discover the lost frame, the missing frame? The sender or the receiver? The receiver. Right? If there's a lost frame, how would the receiver discover a frame is missing? They will check it. It's lost. It's never received.
At the time using a particular time.
Sequence.
Yeah.
How do they discover sequence?
So if receiver has received like 5, 6, and didn't receive 7,
Yeah.
receiver will understand there's a problem. So it will send acknowledge 7 to receive again.
Yeah, I think you're right, but okay, I didn't quite get it the way you said it. Come on.
Sender has a timer.
No, we're talking about how does the receiver know a frame is lost?
So there must an expected frame to receive number and
Yeah, I'm expecting number 5, I got it, and then 6, I got it.
And if there is 8 and 8 is not 7, it just says that
Okay,
it's out of
so-
sequence, so we want to pay.
Right. And what do we call that? Do you have a name for that? Out of sequence. So if the receiver receives an out of sequence frame, then he knows for certain a frame is lost or missing. So that's if it's an information frame coming from the sender. Sometimes the sender only has one frame to send, only one frame. And the sender sends that frame, and that frame is lost, never got to the receiver. How does the system discover this lost frame? Yeah.
In the timer set on the sender side.
So it's only the sender who will discover this. The receiver is not gonna say, oh, the sender should have sent me a frame, but no, that never happens. If a frame arrives, it will deal with it. If it doesn't, then it doesn't know it's gonna be sent.
Is it only for one frame?
If we were only sending one and only frame. Imagine you're sitting here and somebody says, hi, send this, don't send it. Pack it up in a frame and send it. Or a packet. But it's lost along the way. If the receiver doesn't know, you are gonna send it. Okay, so if that's lost, the only one who will discover that is the receiver. Through something called, what's the timer called? The retransmission timer. So the sender, every time it sends a frame, it starts a timer. And after sending a frame, it's an event driven. Either of two events is gonna happen. Either we receive an acknowledgement for that frame, or the timer will go off. So if the timer goes off, we'll send again. The receiver will get up, find, oh, this is for this frame, send it again, and start the timer again. Start a new timer for that frame. And usually in networks, you're allowed to do this a few times. And that's known as the number of retransmissions. Another variable that maybe after 5 or 10 times, we say, okay, we give up. There's a problem with the link. Reset the link. Okay, so sometimes if you keep sending the same frame and the timer keeps going off 5 times or 10 times, this is predefined in the network. The maximum number of retransmissions, that's one of the variables that you will agree on when you join a network. Okay. So we talked about how a number of errors can be handled. Either a bit error in a frame received, or a duplicate frame. If a receiver receives frame number 1, 2, 3, 4, 5, and then receives them again, what does it do with those?
It's gonna send duplicate error, acknowledge what.
Okay, thank you.
Discard.
Okay, the receiver will discard duplicate frames. Sometimes without any action, sometimes they might send an acknowledgement. But I was just looking for, are they gonna keep them or are they gonna send them? How much memory does the sender need? A big one. How much memory does the sending machine require at this level using this protocol, just for this protocol, go back in? This is called go back in protocol. Yeah? No? Hold on, I have a volunteer. Were you volunteering? Pardon?
It should match with the window size.
Window size. The receiver or the sender? The sender. What about the receiver? That's correct. It will need as much memory as it will hold frames based on the window size. The window size says 5, then you must be able, as a sender, you must keep copies of those 5 frames. Okay, if the window size is 50, then you must have enough memory to hold 50 frames, the maximum size allowed. Excuse me. Right, you know what was, how much memory does the receiver need? Does not need to keep any frames. All right, so let's carry on with that. So we've done a number of errors. I'll just go over quick revision, and then we move on to the next issue. The next issue is gonna be link setup, so we'll do link setup. We'll also look at the problems of the go back in, excuse me, and the new algorithm, the next algorithm. And then we'll look at a couple of other issues as well, which is piggyback. Right, a quick example. Anytime a sender, let's say if we have, again, we are working on the go back in algorithm. Go back in sliding window protocol. Go back in sliding window protocol is a protocol that's used to solve a problem. What's the problem that the go back in, that the sliding window protocol will solve? It will solve a problem. Anybody knows what problem it is that's solved by the sliding window protocol? Is it error detection? It's flow control problem. So mainly, the sliding window protocol is there for one reason, to solve the flow control problem, right? Now, what is the flow control problem? Right there, you know what the flow control problem is? When do we have a flow control problem? Yeah? Hold on, I have a volunteer there. Yeah? Say it again.
When the sender is faster than the receiver.
When we have a fast sender or a faster sender and a slower receiver, that's the only time we have a flow control problem. If it's the other way around, we have no problems. Now, what's meant by the modulo? Modulo, guys? What's modulo 8? Well, what is it used for? What's the modulo? Say again? The sequence numbers, no, the sequence, okay. The modulo defines the sequence numbers used. So modulo 128. What does that mean? What's modulo 128? Mod 128.
0 to 1, 0 to 1 and
So we use the sequence numbers. We allocate frame numbers or packet numbers starting from 0 to 127. They are 128 numbers. That's what modulo 128. 128 numbers, but they start at 0 and they finish at 127. The next number, number 128, goes back to 0. And we start recycling those numbers. So of course, guys, remember, let's say we use modulo 8. What's sequence numbers for modulo 8? 0 until 7. 0, 1, 2, 3, 4, 5, 6, 7, and then go back to 0, 1, 2, 3, 4, 5. But remember, guys, when a sender sends, no sender is allowed to send the following frames. 0, 1, 2, 3, 4, 5, 6, 7, 0. Right? They are 9 frames. Are they? From 0 to, yeah, from 0 to 0 again. That's 9 frames. You're not allowed to send 9 frames. Why? Because what if something goes wrong with frame number 0? And the receiver sends you back and say, hey, I have a problem with frame 0. Now we have 2 zeros. You've sent 2 zeros, the first 0 and the next 0. So you're not, window size should never, ever go above the modulo. In fact, it should always be less than the modulo. Okay? This is important. If our modulo is 8, you're not allowed to have a window size of 8. It has to be 7 or less. Otherwise, you could have problems. And the problem is, like if you cover the number twice, you send in the same lot, in the same group, you send the same frame, 2 frames with the same number, and if something goes wrong with that frame, you don't know which frame. If the receiver says, send me that frame again, now I sent 2 zeros, which one? Send that one, so it's not allowed. You're not allowed to have a window size, so there's maximum limit on the window size. It's the module. Some people have to, what's the window size? And they start telling you, oh, they have the numbers we give to the frames. No, that's not how they do that. But there is a relationship between window size and the modulo. The window size must be smaller than the modulo. Just keep that in mind. We have another issue. Now let's do the last error with this, and then efficiency, channel utilization. Right, so let's imagine we have modulo 128 and window size, let's say 11 or 20 or 10, just easier. So now the sender sends to the receiver 10 frames. They start at 0 to 9. And keep copies of those frames, right? Don't forget the copies. Also, don't forget the timers. Timer for each frame. Ideally, this receiver should send back an acknowledgement, but there is a limit to the acknowledgement numbers as well. What's the largest number you can send back here? If they're all received correctly, and the worst case, if they're all lost, none of them, or the first one has a problem, or they're all bad, they all got lost.
0.
Or the first one has a problem, then we send back 0. If the 0 is okay, but number 1 has a problem, well, then we send acknowledgement 1. That's okay, acceptable as well, normal. Maybe number 5 has a problem, then even you send an acknowledgement 5 is also acceptable. So all the numbers are acceptable until 9. If there's something wrong with number 9, we send acknowledgement 9. If there's nothing wrong with any of them, what acknowledgement do we send? 10. So any number between 0 and 10 is okay. These are the acceptable range. You can't send number 11, because number 11 means I've received number 10, which and the standard never sent number 10. Okay? So these are the allowable kind of values for the acknowledgement. The last frame plus 1, the biggest frame number plus 1. And the smallest is the smallest frame number at that time. Now, this user could send back, if the user or the receiver sent back acknowledgement, for example, 92. That's acceptable because, you know, as far as the modulo is concerned, but it's not acceptable now because the receiver receives it by mistake. You know, the sender sent something wrong. As far as the sender is concerned, the receiver sent us the wrong number. Imagine now the number sent is 92. What does acknowledgement 92 mean? That means I received all the frames up until 90 and including 91. When the sender says, hold on, I didn't send 90. I didn't even send 80. I didn't send 70. I only sent up until number 9. So this error is not the kind of error that can be fixed. You can't say, okay, I'll retransmit the frames. Retransmitting of any frames will not solve the problem. Because the receiver is telling you, I received 90 frames from you, and you know you never sent 90 frames, you only sent 10 frames. So this kind of error requires something called link reset. What does link reset mean? It means, hey, we're gonna cancel this communication that we are doing now, and we're gonna restart the communication. We're gonna set up the link. In fact, set up a link is something that happens before you start communicating. We didn't do it. Now we're gonna see that it needs to be done. When you first, two machines physically, they get connected to one another, or you switch your machine on, you're connected to another machine. The other machine is dead, so nothing happens. But the moment that the other machine is on, you realize that. Who knows that? The physical layer. The physical layer always try to send an electric signal. If the other machine is dead, there will be no response. But if the machine is on, the electric signal will continue. Now we have an electric signal flowing between us. So the first one to know that the neighboring machine is switched on is the physical part of the communication system. So the physical layer talks to that machine. They have their own protocol. They say, how many bits can we send every second? What frequencies are we going to be using? They make an agreement on that. And they start transmitting. They're happy with one another. Then they notify the next link, the next level. So they tell the data link layer, hey, physically we're connected to the neighbor. If you want to send a frame, from now on, you can start. So now, let's say this is our data link layer, level 2. But before you can start sending user data, you can't even tell the users you can communicate now until we talk to the data link layer on the other machine. And that's what we mean. We set up the link. We set up a link. But this link is not physical. It's kind of mental. It's logical link. The physical is the only real physical link at the physical level. But now anything we send, can we send it to that level, and that link layer will understand it, and we swap, and we need to, for example, you want to send a frame. What's the maximum frame size? Can you send, 5,000 byte frame? No, we must agree with the other side first. These are a few things that we need to agree on. And also, what's our window size? We need to agree with the other side. How do we agree? Remember, we said window size and modulo must be agreed with the other side between the two machines. That's when it happens, at the moment of setting up the link. And setting up the link happens at the very start. The moment the physical layer tells you, hey guys, we're linked physically, then you must link yourselves at the data link level. And that's what we do. So, but let's say we've done the link setup earlier on, but now there's an issue, so we need to do it again. So these are the steps required for the operation that's called link setup between two machines. Follow me. So first, when do we start it? When do we actually perform link setup? At the very start of the communication. Before we communicate at all, we must do a link setup. That's the first time we do it. And it could be the only time we do it. We don't need to do it again because everything's going fine. But sometimes, like this problem, the problem that we have an error that cannot be fixed by retransmitting frames. Like remember, every problem we had so far, lost frame, bit error in a frame, duplicate frame, all these can be, we resend again another copy and we're happy. We keep a copy, by the sender keeps copy until you tell me you've received it perfectly. That's the only time I'll wipe it off. Otherwise, I can send you back copy and we solve the problems. But in this kind of problem, it cannot be solved. If I sent you 10 frames and you say to me, oh, thank you, I received 80 frames. I say, no, there must be something wrong. And whoever discovers there's something wrong, the sender or the receiver can, it's like, for example, from the sender, just another example of how does the receiver discover there's a problem. If, for example, the receiver says to you, okay, I've received 10 frames from you, send me the next one, so you send him the next 10 frames. So now the receiver says to you, okay, send me frame number 20, and you start sending frame number 90. He says to you, oh, where are you going with 90? I haven't even received 30 or 40 or 50, so it could be the problem can be caused by the sender. One of them can go mad, maybe, an error in the program. Usually they're well tested. All the software is well tested before it's put on a network. And there's actually special programmers who program testing communication systems that they are based, or they work as per the protocol. If the protocol says if there's a problem, try it 5 times and then disconnect. They test you. They have another program sitting on the other machine. You communicate with you, and they intentionally give you this problem 5 times and see, do you go by the protocol? Do you disconnect as the protocol says or not? So that's called protocol conformance. So you might, if you go into programming in a big way, and you go into communication, networking, and you start programming, communication between devices. It's like programming for operating systems, system programming on computers, but this is network programming and actual communication modems and routers and devices like that. But anyway, the problem can happen by the sender or the receiver for any reason. But let's say it happened. So whoever discovers it, the other party will say, okay, it will start by sending a link reset request. So we call it reset request. This time it can be sent by the sender or the receiver. It should be actually, in this case, it should be sent by the receiver, reset request. Because the sender is the one who sent the wrong numbers, and the receiver discovered to say, I can't continue communicating with you. There's no confidence between the sender and the receiver. Yeah.
So see what that's in 90 degrees.
Yeah, in this case, the receiver should be sending the reset request. So, so the acknowledgement 92 is actually so this is the one who discovers. So in this case, the sender should be sending the reset request. Okay, I'm gonna cross this. So the sender will start the reset request because it's the one who discovers the major error. So what are the steps involved? And if the two parties, one of them says, hey, let's reset the link, the other party, even though it's a request, it's not an optional request. You must go ahead with resetting the link. He cannot say, no, we'll continue. That's not allowed in this particular case. Anybody who sends reset request, the other party must go along with it. It's not optional. Now, what are the steps involved in the reset request? If you have any copies of any frames, yes, sir.
Sorry, what's this error called? This error.
This is one error that cannot, this is the type of errors that cannot be solved by retransmission.
Yes.
This is how they're classified.
Yes, but does it have a name? Like really out the lost error?
I don't know, you'll find a nice term that describes it. Errors that necessitate reset, link reset. Until you find a good one, a better way.
Well, how does the receiver discover that error?
Okay, well, we've seen how the sender discovers it. I gave an example of the receiver. For example, the receiver didn't send 92 this time, it sent 11. That's a normal. So it's waiting, the receiver is waiting for frame number 11, but the sender sent in frame 88, 89. So hold on, I'm waiting for 11 and 12 or 13. You're sending me 88. That's way outside the window, right? If it sends the repeated ones, from the previous window, it will be accepted, it will be just. But if it sends one that there's so many of them beyond one window, then it's refused and it causes link setup. Yeah? Say again? Bit error? That's one error. No, what kind of error is called bit error? If I send you a frame, but there is one bit flipped. So CRC will discover that, or parity, or checksum. Error will tell you, there's an error in this frame, discard. That's that kind of error. Bit error is one or more bits have flipped during communication. That's discovered by the receiver after, using the CRC or using parity system. Now, that's it. The link request has arrived and we must reset the link. What does that mean? It means if you have any copies of any frames, delete here or delete all copies. Delete all frames, copies, or anything you have in your memory, or frames or copies, delete them. Hamush. And then zero-wise, all variables or counts, variables or counters. So if you have a program with this X counter, or the next frame we expect to receive is number 11 or 12, no, put it back to 0. All counters, all things are zero-wise. Reset all, that means switch off. Reset all timers. If you have any timers, if you sent any frames and the timers are taken away, go and turn them off. Basically, we're clearing the system. We don't want anything happening from the previous communication. Notify your users. The users higher level on your machine that are maybe downloading a music file or a video or communicating with somebody, say, sorry guys, the link is disconnected. We're gonna reset the link. I mean, it's tough luck if you've been downloading a file for 20 minutes, a video, and you're now at 98%, it's almost there, it's gone. So this is like you lose the internet. When you lose the internet, and then a few minutes later you get the internet, you were downloading something, it was canceled. Do you start downloading again from the beginning, or do you continue from the point you were at? So it depends on the program you're using, the download program that you were using. If it was written by a good programmer, they'd keep a log. Everything you do through the internet, you're receiving something, you keep a log, and you say, right, we've got 78, 79, 80%, 30, whatever, then the break happens, then you know exactly how far you downloaded. And when you rejoin, you look at the history first and say, oh, we were downloading before, we have something not finished. We know exactly how much of it we got. So if that programmer is good who programmed the downloading, will be able to overcome breakdown in the internet, including link setup. If you did write that program, and if you were a bad programmer, now I know you were not, but if you were a good programmer, you would have done that. You don't restart. So anytime you write a program that does that, take that into consideration. You'll save the people who will use your program a lot of time, and a lot of cursing, will not follow you for the rest of your life. Because every time somebody uses your program is bad. It's who wrote that, and they start using bad language on that. So as a good programmer, please try to minimize, the pain to users who use your program. Right. So we have to tell our users, sorry, they are disconnecting the line. So maybe some of them, okay, they need to understand. And then you're going to set up the new link. So setting up the new link involves negotiation. So it's a process called negotiate parameters. So parameter negotiation, parameters. Parameters, these are the variables that we're talking about, including window size, modulo, retransmission timers, length, retransmission, how long, well, length is one thing, and also number of retransmissions, retrans. What do we mean by number of retransmissions? If, for example, I send you packet number 5, 1, 2, 3, 4, 5, and then you say to me, hey, number 5 has a problem. I retransmit it, start retimer, and send it to you. Yeah? I know, that's intentional. Right, so just stay here for a sec. So one packet had an error. I send it to you, and then it has a problem again. You say, send it again. I send you the same packet. You send it to me. How many times do we continue? There is a limit, and that number is called number of retransmissions. And if we exceed that, then that's it, we reset the link. So that's another one of those variables that are used. There are plenty of variables, I don't have them all. What's also the maximum frame size or packet size? That's also need to be agreed. How big is each frame? 1,000 bytes or 4,000 bytes? Maybe I can't handle 4,000 bytes, so maybe. Of course, all these variables are agreed between you and the network. When you join a network, they say to you, okay, you can use any numbers you want, but you must be able to use, for example, 1,000 kilobyte. That's the default value. There are default values for the network. Maybe the retransmission timer, for example, is 30 milliseconds. You and your neighbor can agree on any number, but if you disagree, you must be able to perform the default. When you join a network, it has the default values. You must be able to run those, use them. You can't say, you talk to another neighbor on the same network, he says, let's go for 50 million, now we go 60, 20. Hey, if the negotiation happens once, if you agree on the numbers, good. If not, use the default. So most people just use the default right from the start. But you can change those values. Number of retransmissions, the length of retransmission timer, all those. Right, so here, what was it? It's a negotiate parameters, like window size, modulo. Are we going to be using modulo 8 or 128? Retransmission timer length. That's the length of the retransmission timer. And then the number of retransmissions. Do we go for 20 retransmissions or 7 or 10, whatever the number is? And the maximum frame size. There are a few parameters you need, obviously, to look at the protocol to find all the parameters that are negotiated. Right. But once you negotiate those parameters are sent in the frame. In the frame, that's called retransmission link reset request, and you put your parameters in it and let the receiver come back with responses. And sometimes both discover there's a problem at the same time. They both send link request. That's also acceptable. And we'll consider it like a response. If I send you a request and you send me a request, I will consider your request as an acceptance to reset the link, and vice versa, you will accept my link request if we happen to send them at the same time. But in this case, the sender will send it first, and the receiver will look at it and say, yeah, we'll send the response and start deleting copies of packets, putting everything 0, notifying our users, and we go back to that point. And finally, and the last thing, they both must send, they must exchange something called receiver ready, RR frame. And the RR frame, it is just an acknowledgement. It's an acknowledgement frame, actually, with acknowledgement 0. And this guy must do it, unless you receive it, will not be communicating with you. We'll know you're ready. And also this guy has to also send RR. What does acknowledgement 0 mean? Normally, what does acknowledgement 10 mean?
It has received until up to 9 and it is ready to receive.
Thank you. That means we are acknowledging all frames until 9. What else could it mean? I'm expecting frame number 10 from you. So this acknowledgement 0, it means I'm expecting frame number 0 to be the first frame you send. But at this point, we call it receiver ready. That's a way of the receiver. One machine tells the other machine, okay, I'm ready to start communicating with you. And by the way, that's what I expect, frame number 0. And this is the last thing, the last step of the link reset. After that, we continue communication again. But all communications to us is going to start again at frame number 0. So if if two users were talking on Messenger, that's no problem. They just continue and they continue talking. But somebody was downloading a file and kind of got disconnected. It depends on their application. Do they want to? Is their application geared towards continuing from where they left off, or they have to start again? It depends on the programmer who programmed their application.
Clearly, if we or 126, if the hardware is there, then here every 128 if the reset link is happening, so then it would be very slow. If we are doing reset links for every time, then what the solution?
If we keep resetting the link, there's a problem with the link. I don't think it keeps account of the number of resets that happen in the last few minutes. But if you as a user, you notice that you are resetting continuously, then you know there's something wrong, something else is wrong. I don't know what it can be. Probably with the software it needs to be reinstalled because it's not the physical layer. The physical layer is connecting you. But it could be something wrong with the physical layer as well. It needs then more, troubleshooting than to find out why is the link is continuously resetting. Yeah, do you have a question? Or somebody had a question?
Follow about this.
Yeah.
Maybe it could be the transit issue between center and
Transit.
issue between the center and the center.
That's physical layer problem. Yeah, it could be. Yeah, it could be transmitter problem. Yeah, of course. Yeah. Then that's where you'll need a troubleshooter, somebody who works on network, and say, okay, why are we getting a lot of relinks? It could be transmitter. So yeah, that's where you start going into debugging and replace the transmitter and see if it works. And then if it doesn't, if you still have a problem with two physical transmitters, then you start looking at maybe the software in this one. Maybe some of the, you get to that stage, then you're a network expert, you start. Right, so that is called link reset. When two machines are first switched on, your machine, you switch it on, and you find your neighbor is not connected. You cannot communicate with the neighbor. Let's say a few minutes later, the other machine is switched on. Now the physical layer can sense that. And they tell you, right, physically we're linked. It's up to you now, data link layer. You can start sending user data. Now you know, as a data link layer, you cannot start sending frames until you talk to the data link layer on the other machine. That's through this operation, link reset. So when the machines are switched on first, physical layer is connected. Now we get notification, physical layer okay, transmitters work, no problem. Then now the data link layer has to send a link reset request. You set up a link with the neighboring machine. It has to be done. This is the operation that needs to be done at the very start. So we negotiate, we put 0 values, we're still new. We agree on the values and we exchange receiver ready. We agree on the window size, on modulo, on retransmission times, number of retransmissions, and we exchange receiver ready. That means we are ready. And we notify the user, which is our user is going to be the network layer, but we notify whoever is up above there. Let's say the user now knows it's ready, they can start communicating. They say, oh, the link is back. That's when they say the signal that you send them from the data link layer. Something appears on their screen, they say, your link is connected now with the neighbor, you can communicate. All right, so this is another error that can happen at this level. And it's also, it's one of the issues that are in the go back in algorithm. So I'm going to see an issue. This go back algorithm is one of the most efficient, one of the most, simplest and easiest algorithms that have been around since the 70s with minor modifications. So, but they have a problem. And here's the problem. If you're asked what's wrong with the go back in algorithm. The go back in algorithm, suffers from one issue sometimes, and that's channel utilization. Channel utilization, that's using the transmitters. How efficiently can you use them? Normally, you should use them only for transmitting data, but sometimes this one starts duplicating sending data. And this is the problem that can happen. Imagine, again, I'm going to have the same example. We have a sender and a receiver, and we have a window size or modulo 128, and we have a window size. What's the maximum window size we can have in modulo 128? Pardon? Oh, speak it up a little, give it a bit of amplification or repeater. Thank you. So it has to be less than the modulo number. So what, 125 is okay? 127 is the window. The maximum window size has to be one less than the modulo. So the window size here, I'm going to use 100. Right. Let's say we're going to use 100, the window size. So now, all right, guys? So this guy is going to send frame 0, 1, 2, all the way to 98, 99, 100 frames. And it's going to keep copies of those frames. Okay, if the modulo is even bigger and the window is bigger, and you can be sending, 1,000 frames. Let's follow how go back in works. Go back in gets 0, 1, 2, 3, all the way to 99. It will receive, this transmitter will work, and these frames will be put in, in a queue and handled by the receiver. Imagine this situation. This is the worst situation. Frame 0 has a problem. There's one bit flipped wrong. We don't know which bit. So what do we do with frame 0? We send it to the user, to our user? No, discard it. Right? Is that what? Yeah. Discard and send back acknowledgement. What acknowledgement number do we send? 0. Yeah. That means, hey guys, there's something wrong with frame 0. Remember, if the numbers, the sequence numbers that we had here, 0, 1, 2, 3, all the way to 98, 99, and then all the way to 128, or 27, so we're not allowed to use 28, and then they cycle back to 0, 1, 2, 3. But this guy sent us all the way to number 99, so it's edging here to send me frame number 100. But when you send this acknowledgement 0, it means, no, don't send 100, go back to number 0 and start sending. That's why they call this go back. This is the go back N. Go back N, that means go back to this number that I send you in the acknowledgement. That's the name of the protocol. Go back N. N is the number. So it's like I'm saying, go back to 0, go back to 10, whichever frame has an error, I'd put it in the acknowledgement. And that's like, don't send me the next frame that you keep in your mind. You're going to send me number 100. No. Go back to this number and start sending. This is how the go back N works. And then number 1 is good. Number 2 is good. Number 3 is good. 4, all the way to 99. What do we do with these frames? Do we send them to our user? Yeah. Without the first frame. Like if you are watching a video, you skip the first part and then you watch the rest of them.
Oh, discarded.
So frame number 0 has a problem. We discarded it. Now frame number 1. If you're downloading a file, you're not going to have the first few pages of that file. So in this system, we never ever send frames out of sequence to our user. In the go back in, we discard them. Before we receive this frame, we have a variable. The receiver has a variable called NR. The next frame I'm expected to receive is 0. That's one of the things we initialize at the beginning. Now, we received number 0. That's good. We check it, but we find it's a problem. We don't say, okay, now we're expecting number 1. If this has a problem, we discard it. We're still waiting on number 0. We find number 1 now, we received 1, not 0. That's not the one we are expecting. So we discard number 1, even there's nothing wrong with it, but it's out of sequence, right? That's not the one we're expecting. Now we need number 0, but we find 1 and we find 2, 3, all the way to 99. All these are discarded. So this is the problem with this system. And the sender will receive frame 0. That means go back to 0. It already has copies of all these frames. So start transmitting them again. 0, 1, 2, all the way to 98. This is the problem, 99. This is the problem with this system. You send lots of frames because one of the frames, if the first frame is bad, this is the worst situation, all the rest of the frames are discarded. If maybe the first 10 frames are good, the problem with number 11, then you discard 11 and 12 and 13, and from anything that follows the bad one are all discarded. So the worst situation, if we have a window size of 100 or 200 or 1,000, and the first frame we receive is bad, the sender, all the time it took to transmit all the frames, it's a waste. They're all discarded, and we ask them to be retransmitted again. And this way, you're using the channel really inefficiently. You're resending good frames that have been received and checked, and remember, the receiver error checked each and every one of them, spent a lot of processing time, a lot of transmission, and they took a lot of memory space everywhere, and we discard them. So this is the disadvantage of this system. It does not use the channel efficiently. So there was a modification made. So this is really the only major problem, the only problem with this go back end system. So another system was introduced, or a modification of this system. Anybody knows what it's called? They're all sliding window protocols. Yeah?
Selective repeat.
What is it called? It's called selective repeat or selective reject. So it's like this one, but don't reject everything, only reject the bad ones. And it's asking the sender, only resend the bad ones, don't resend me the good ones. So it's again, sliding window protocol, but it's instead of go back end, this is called selective repeat or selective reject. That means don't reject all frames, selectively only reject the bad ones. So it's similar to the previous one. This is how it works. If you're asked to describe the selective repeat or selective reject algorithm, the sliding window, it's a sliding window protocol, and this is called the selective repeat. So again, let's take the similar examples. Let's say window size 5 and modulo 8. We have a sender and a receiver, and the sender sends, what frame numbers would the sender send? Abdurrahman. Pardon? The window size is 5. I didn't hear you, say it again. 0 to 5, 0, 1, 2, 3, 4, 5, right? 4 only, yeah, thank you. What else does the sender do or send? Or yeah, keep copies of those frames, those 5 frames, 0, 1, 2, 3, 4, and keep timers or start timers for these frames. All the way, timer 0, 1, 2, 3, 4. Now, imagine if there was an error in 1 and 3. Imagine we had 2 problems. Number 0 is okay. What do we do with 0? Send it to the user. Number 1, we discover there's an error. If we were doing the go back in, delete it and say, come on, send us number 1 and all the ones that followed, because we're gonna reject everything else. But here we will not reject everything else. Number 1 has bit error, discard. And send back, this is called acknowledgement, but it's a special acknowledgement. It's called NAC, it's negative acknowledgement. And negative acknowledgement applies to one frame only. Remember, the acknowledgement, you put one number, but send me this number and all that follows it. This one only, please send me this frame only. So we put the frame that has the problem. But we continue checking the next frame. The next frame is 2. 2 is okay. What do we do with it? Can I send frame number 2 to the user? Same question to you. We had frame 0 is good. We sent it to the user. Frame number 1 has error, discarded. Number frames 2 is good. Can I send it to the user? Yeah? So if you have a file of 3 pages, that page, the middle page is gone. Can you send this to that file to store it? No. You can never send to a user anything out of sequence. To the user, because the user is going to take it and store it, maybe a file. So don't send things out of sequence. So number 2 is good, but in the previous system, they go back in, we discard it because it's out of sequence. With this one, buffer it, store it in memory, buffered. That means keep it in now, you need special memory. The receiver now needs special memory here. Like the memory that the sender has at the data link level, also now the receiver needs buffer. So we keep number 2. It's good, but we can't send it to our user, but we are not discarding it. Now, we get the next frame, number 3. Number 3 has an error, or lost, or whatever it is. The moment we discover it has an error, of course, we discard it, and we send another negative acknowledgement. As you notice, negative acknowledgement only applies to one frame only. You can't say negative acknowledgement 5 frames together in one negative. Each one of them will require a separate negative acknowledgement. It's only a header. Acknowledgement and negative acknowledgement, just the header part. Doesn't have any data in the frame. Maybe 5, I don't know, 5 to 10 bytes altogether, depending on, on the protocol and the network and all that. But it has one space for a number, and that number is called the frame number that has the problem. So we put the number 3. But when we are using acknowledgement, that 3 means send me 3, 4, 5, 6. But now NAC means only send me only number 3. So, and then let's keep on going, because this guy keeps checking, is there anything on the online? Yeah, and memory, yeah, there's another frame, number 4. Number 4 is okay. There's nothing wrong with it. Shall we send it to our user? No, buffer it or save it. Keep whatever word we use. We use buffer because you put it in buffer. Now you need memory. Now, in the meantime, the sender would have received NAC1, negative acknowledgement for frame number 1. So anytime the sender receives negative acknowledgement, take this frame and send it to me immediately, only. So it takes number 1, frame number 1, and reset the timer and send it, and restart the timer again. So frame number 1 is sent. Now it also will receive NAC3, so also send number 3. As you can see, guys, notice that the lines are always going downward. Don't draw me a line going that way upward, because if this is the time of sending at 3 o'clock, you don't want to receive it before 3. You have to receive it afterward. So make sure all your lines are always tilting downward from the source to destination. Right, so this guy now receives number 1, checks it, and it's okay. What do we do with number 1? See, the last one we sent to the user is number 0. This is now the correct sequence. 0 has already been sent. So we take number 1 and send it to the user. Now we have number 2 is saved. Now it's time to send it. So we take it out from the buffer and send it to the user. So number 2 goes there. So 1 goes there. We followed by 2. Do we have 3? No, we don't. We wait, and suddenly number 3 arrives. We check number 3 is okay. Oh, the last one we sent is number 2. Now we can follow number 3. And then this number 4 is buffered. Perfect. Now that's our window size finished. Now we can send acknowledgement. See, this is acknowledgement, not negative acknowledgement. What acknowledgement number shall I send? Are you following us? No? So now we got all these frames, 0, 1, 2, 3, and 4. They're all now sent to our user. And we send an acknowledgement to this sender. What acknowledgement number shall we send? To tell them we got all frames 0, 1, 2, 3, and 4 are received. 5. So acknowledgement 5. What does acknowledgement 5 mean? I know what that was. Acknowledgement 5. What does acknowledgement 5 mean in general? Yeah, so that's exactly what now we are telling this. All these frames up to number 4 are received correctly. What else could it mean? What else does it mean? No, and that's the frame that I expect from you now is number 5. These are 2 meanings. And also, if they send number 5, we tell them there's a problem with it. But now if there is a problem, we use NAC in this system, negative acknowledgement, and it only covers 1 frame only. So now this guy receives acknowledgement. He does delete all these. We no longer need them. Once the acknowledgement 5 is received, we don't need those previous frames. We send the next 5 frames. Okay, so what frames are sent? What frame numbers are sent this time? We're using modulo 8, window size is 5. 5 and 6 and 7, right? 0 and 0. Okay, right. And that's how errors are handled in this algorithm that's called selective reject. So now the question is, which one is better, selective reject or go back in, sliding window protocol? This one is better, the selective reject. Why?
Those frames are on message of all times. The first packet has an error, the rest of it's a wastage of time.
So we don't have to retransmit the good frames, we only retransmit the bad frames. So this one uses the channel better. Yeah. Okay, so this advantage of this guy here, this algorithm, it's better at utilizing the transmission channel. We never send again a good frame. We only retransmit the bad frames. We pick the bad ones. Selective, we absolutely select which frames to be retransmitted. So that's the advantage of this. But what's the disadvantage of this? The disadvantage of this compared to the last one, now you have to buffer these frames. That means you need memory. Like the sending machine, the receiver also needs buffer. How much buffer does the receiver machine need? Any idea? What? The window size. Okay. No. Why do you need the windows? How many frames do you want to save? Let's say 5. Why 5? Here are the frames 0, 1, 2, 3, 4. If 0 is bad, what happens? And the rest of them are good. You're gonna save 1, 2, 3, and 4. They are 4. You don't save the bad one, 0. Okay. So you don't need 5. The window size is 5. Okay. No. Is his question? What if this one is bad and 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 this one is bad? You say we need to save the 5 of them? We don't need to save any of them. Anything that's bad, discard it. You only save the good ones that are out of sequence. So the worst case, it could be just, for example, they're all good except number 4. Which one would you save now? They're all 0 is good, 1 is good, 2 and 3. They're all good. Number 4 is not good. What do you save? You save nothing. You don't have to save anything because you send this to the user and this is okay, correct sequence. Send them all to the user. 4 is bad, discard it. You save the one after the bad one. There's nothing after this one. So the easiest situation is if number 3 goes bad in this case. So you have to, and 4 is good, then you have to save 4. But that's worse If number 2 is bad, 3 and 4 are good, then you have to save 3 and 4. The worst situation, if 0 is bad, then you have to save 1, 2, 3, 4. So anyway, the number of frames you need to save, window size minus 1. That's the maximum amount of memory you need. With the sender, how much memory does the sender need? The sending machine, how much memory does it need? It has to save a copy of every frame it sends, so window size. So the sender needs window size, the receiver in the selective reject needs window size minus 1 of frames to be able to be saved in its memory. So be careful. So the selective reject is better than the go back in at utilizing the channel, but it's the go back in is better than the selective reject because it doesn't need memory at the receiver. This memory can be a problem. But which one is in use today? This is an improvement. This is a theoretical improvement. It works, and it's been implemented on few networks, but you need to do it on all networks and all machines, and anything like that takes a long time to do, and it's expensive to change. So for now, still the go back in is the most commonly used algorithm. And it's rarely that you need to deal with that problem that we looked at. We looked at a worst situation problem. It doesn't often happen. Now, one last thing I want to talk about before I let you go, guys. I know you've been bombarded with too much stuff. Okay, every example I gave, guys, I said there's a machine here, and that's the sender, and there's another device here, and that's the receiver. But remember, in a network, imagine this machine and that machine. They're routers, for example. And they're connected as part of the network, or maybe there are many users connected to this one. And all these users are sending data. Some data is going that way, some data is going that way. And when it gets to this point, some data is going in that direction, some of it's going in this direction. And also, this guy is sending information in this way. Some of it is going that way, some of it is forwarded here. The point is, see these two devices? They have data flowing, packets are going in this direction, and also they have data going in the opposite direction. Like airports, Rome and Paris, there are airplanes flying in the opposite directions. I've always been just using one example. The sender is here and the receiver is here. But don't forget, this machine is acting as a sender, and this machine is also acting as a receiver. It's not always the same. This machine is not always the sending machine. It works, it sends, but it also receives. But anything that it receives, they use a different sliding window for traffic going in the opposite direction. So when this one is a sender and that's receiver, they'll have another kind of device. So this one, let's say this is machine A, it's sending, and machine B is receiving. But also, machine B is actually now sending. So this is normally the sender, but now B can also be a sender, and machine A can be a receiver. So information is sent in both directions at the same time. When A was sending, we had a modulo, we had a sliding window, we had a window size. Also, they're different ones, but when B is sending, they have their own modulo, they have their own window size. They could be sending frames number 12, 13, 14 in this direction, 12, 13, maybe 14 in this direction, and maybe in this direction, we're sending frames number 70, 71, 72. and they have their own window size. So every direction is separate traffic controlled by its own sliding window protocol, its own variables, its own, window size, its own, everything is separate. So don't mix those two, but remember that they're both acting as senders and receivers. Frames are continually flowing in both directions. Now, so you can actually take that diagram, put it over this diagram. Just, you have to keep the two separate. So I'm keeping them separate this way, but imagine it's the same machine, B's, receiving and sending. But let's say this guy sent these frames, 70, 71, 72, window size is 3, so it should expect back an acknowledgement. What acknowledgement should get? 73, if everything is received correctly. Right. Now, what these people are saying, instead of sending that packet, separate packet, in this direction, that carries that number, 73, that's only, we want to pass this number to this side. But we are already sending frames in this direction. And A occasionally sends an acknowledgement this way. Like in this case, if B was the sender, it was sending packets 2, 12, 13, 14, and this guy should send back acknowledgement 15. That's the normal. Now with these network people, they say, let's get rid of these acknowledgement packets. Let's save number of communication or traffic on the roads, on the network. So they say, listen, if I am sending you these packets 70, 71, 72, and you as a machine receiver want to send me acknowledgement, why don't you look? Are you sending any packets in this direction? They've got nothing to do with this. These ones here, they've got nothing to do. And if there is, it's like, somebody in Cork, right? And you ask them, can you send you maybe, you have a present, they're going to send it to you. You can say, go to the motorway, see if there's any car coming towards Dublin, and ask them if they take this, they take that present, put it on the car. It's got nothing to do with that car whatsoever. But when they get to Dublin, you'll be waiting for them, way back, can I have my present? See, so somebody carrying that packet or that number. So saying, this guy sends 70, 71, 72 is waiting for a number, 73 normally, acknowledgement. This guy says, okay, I can send you a separate packet, but instead, hey, I have packets number 12, 13, 14 go in that direction. It's nothing to do with this number. But on every frame, right now, on every frame, here's the frame that has data, that has the packet carrying the packet. It has source address, whatever it is, destination address. It has a sequence number, but it also has acknowledgement number, which has got nothing to do with the rest of the packet. It's just like a car traveling from Dublin to Cork. It has a spare seat. Anybody can jump into it. They've got nothing to do with the people who are traveling. It's like you thumbing for a lift. If you go to the motorway, the start of the motorway, you want to go to Limerick. You go on the road to Limerick and you start thumbing for a lift. A car stops. You don't know them, they don't know you, but they have a spare seat. You sit in that seat until you get to Limerick, you get out. This is exactly what's happening now. If there's a data packet going in that direction, there's a bit of space always left in every packet, enough for one number. So this guy puts the number 73 in it. It goes there. When it goes there, first thing, this guy takes it out and gives it to the other side. So we take the 73. Now, it won't be in our packet. It'll be in one of these packets that we don't normally see. This guy doesn't deal with them, but they're in the opposite direction traffic. So we take that number 73, give it to this guy, so as an acknowledgement. So this is known as piggyback acknowledgement. Do you know what a piggyback is? Piggyback is get a ride, free ride on someone's shoulder to the other side. They usually do it to children. They take a child, sit, walk up the road and drop them. So that's a free ride, basically. And that's exactly what we do. We look for any packet going in that direction, like any car going in that direction. So can we put this number there? It gets to the other side, we take the number out. So packets are traveling anyway, so there's no need to send a packet, a separate packet. If there was no data packet going in that direction, well then no, we just send the acknowledgement, separate acknowledgement packet. So this is called piggyback. Piggyback acknowledgement. So what's the piggyback acknowledgement? Anybody can put it in any words? No. No, you look like you're very confident. What's a piggyback acknowledgement? Can you describe it to the rest of us? Have a go. Right, have a go.
So machines are both distributed so that sender simultaneous.
Yes, it's important to say if the machines are communicating in both directions. That means there's data going this way, data going that way.
Yeah, so when sender sends packets, the receiver also can send acknowledgement packet to the
Okay, thank you. So instead of sending a separate acknowledgement packet in one direction, we can look for any data packet going in the same direction and put the acknowledgement number in the space provided in the header of that packet. Every frame or every packet will have a spare field called acknowledgement. It's nothing to do with that packet. It's got nothing to do with that frame. It's just a free space. You can put any number in it. We go there, we take it out. That's all it does. It just delivers an acknowledgement packet, and it's known as piggyback acknowledgement. And the purpose for that, to reduce the number of packets that are sent, even though they're called acknowledgement packets, but hey, less acknowledgement packets. Now, what's the purpose? Why do we use sliding window protocol? What's the main purpose for using this protocol that's called sliding window protocol? Why is the sliding window protocol used? Why don't we do without it? Because it actually slows down, communication, slows down the sender at least.
Maybe for efficiency.
It's for efficiency. No, it might reduce efficiency. We can do without it. It can cause problems, coding issues. The reason why, guys, do we bother and use sliding window protocol? It solves one problem. The sliding window protocol solves one problem. Do you know what it is? What did you say? You did. You're fine anyway. Two people said it already. What's the main purpose for using sliding window protocol? To solve the flow control problem. Right? What's the flow control problem? No, making sure. There's a problem. Describe the problem. Thank you. If we have a faster sender and a slower receiver, we have a flow control problem. Okay, that's in summary. But that's not. Okay. Any more questions, guys? You want to go home early? Who is in a hurry? Okay, tell me. Right, sit down, sit down. We have a missing frame. Who's going to discover the missing frame first? The sender or the receiver? Receiver, good answer, but not necessarily an accurate answer. Who discovers the missing frame first?
Depends.
Yes, good. It depends now. It depends on the type of the frame that was missing.
If it's out of sequence,
Give me one time.
if it's out of sequence, receiver will receive it.
Yeah. If it's out of sequence, if the frame was received in the middle of a number of frames, like 1, 2, 3, and 4 is missing, 5, 6, the receiver will discover first. How would the receiver discover? Well, the sender discovers. If we have, right, so we won't mix you up. Here frames sent by the sender. Frame number 1, 2, 3, 4, 5. Number 3 is gone missing. There. Number 3 is gone missing. Who's going to discover that? The receiver. How is the receiver going to discover it?
So my receiver received frame 4.
Out of sequence. So if you receive an out of sequence frame, then that's how the frame is missing. No, now the acknowledgement frame is missing. Who's going to discover that? There was nothing missing here, and the receiver sent back acknowledgement 6. Guys, I know the answer to these questions, and you're gonna get these questions in the exam, and you better get them to know the answer. If you don't want to hear it, you know, you can leave. You have 4 minutes left, so you can go. Otherwise, please stay quiet. Now, we send 5 frames this way, and the opposite direction, the receiver sent acknowledgement packet. That packet is got lost. Who's gonna now solve the problem? How's the problem gonna be solved? Thank you. So the sender is gonna discover it, and it's through the retransmission timer. Okay, that's how they're gonna be discovered. If the sender does not receive acknowledgement, then the timers will start going off. Right. We have a lost frame. Okay, what does acknowledgement 0 mean? It can mean a number of things, maybe up to 5 things. It can mean one thing, acknowledgement 0. What does acknowledgement 0 mean? Everything what? Like what? Give me one number, like this number was received. Okay, not very accurate. I don't know how many marks you get in that. You put that answer in an exam question. Any idea? One reason, one meaning to acknowledgement 0.
They are waiting for the first package, zero package.
Thank you.
Receiver ready.
One meaning is receiver ready. When do we send receiver ready? When is receiver ready sent? Hold on. Yeah? At what? No, hold on. All right. Okay. Now there are 2 questions floating. The first one is, what does acknowledgement 0 mean? But this brought in another question. Receiver ready. What's receiver ready? When is it sent? After a link reset. The last thing in resetting the link, we send receiver ready, which is acknowledgement 0. Now that's fine. Now give me another meaning of acknowledgement 0. They could be frame number 0 has a problem. Please resend the frame 0. What do you want to say? That you've received everything? No, not the window side. It doesn't. No acknowledgement will mean that. Any other meaning? What's the other meaning to acknowledgement 0? Yeah. I expect to receive frame number 0 from you. Any other meanings? Resetting is done. Okay, now wait. Okay, we completed reset. Here's the last thing. Receiver ready. We've already said that. So it's reset is done. This is the last step of reset. Receiver ready. Let's call it receiver ready. Or frame number 0 has a problem. Or what else? And I expect frame number 0 from you. These are only 3 readings. Anything else? What other reason? What does other meaning does acknowledgement 0 mean? Yeah, you put your hands up. Yeah, go on. You're stretching and jumping.
Yes,
The last frame was good. Say again?
You mean the last frame you received was multiple size?
No. It means it's an acknowledgement. Acknowledgement to what? That's the thing you haven't said, guys. Pardon?
That's what I said, multiple size.
No, nothing to do with modular size. What's acknowledgement 0? It's acknowledging what frame number? Acknowledgement always acknowledges the one before this. It's not acknowledging 0, it's acknowledging what's before 0. What's before 0 now?
What is modular?
Yeah. Pardon?
Always modular.
Yeah, it depends on the modular. That's when you. Yeah, but it's. So it's number 7. It's telling you if the modular was 8, that means When you're working on modular 8, you receive acknowledgement 0, that means number 7 is okay. We've received 7, 6, and 5. If it was modular 1 to 8, it means we've received 127, 126, 120, and so on. I knew you were beating around it, but you need to be a little bit clearer in your answers. Okay, I think it has another meaning, I can't remember, but it may be the frame has an error or lost. If frame 0 is lost, you get 1. What do? You send acknowledgement 0. Okay, thank you guys. I'll see you next week. There'll be 2 tutorials now, error detection and flow control. I'll put 1 tutorial this week, another tutorial next week. So you'll be busy for the next 2 weeks. Good luck to you.